so this was the output when we ran this on the unres code. And so we can quickly see what are the major functions. Although you notice that we've got a function that glaringly declares itself as setup. And so we know that we didn't run this long enough because this was part of our setup here. But setup actually takes a long time, as I mentioned, and so you had to run a really long time to get this off the list. But you can start to see which are the major functions there. Okay. Okay, so now we've been able to sort of take a quick snapshot at what are the important functions, or at least what's the overall performance of the code. And now we're going to go ahead and instrument those functions. And so we're inserting other functions into our source code to measure performance. This will give us precise information about where things are happening, but there can be high overhead associated with this, and that can affect the accuracy of the measurement. So the key thing will be to only instrument, if you want really accurate timings, to only instrument those functions that are important or critical to what you're doing. So we're going to talk now for a while about tau, which I mentioned is sort of the Swiss Army knife of performance tools. It can sort of do all the things that we already talked about. Some of these other tools are designed to get quick information about code, and so they can do it more easily. They can do it without overhead, and so they're good for that. But if you really want to drill down, then a tool like tau becomes important. But you can also use tau for some of those previous steps too, and you may prefer to do it that way. But you have to take some precautions, which we'll talk about to control that overhead. We can look at you can look at analysis on any level using this direct instrumentation, and it's all integrated with performance counters, and you can look at performance and serial and communication and so forth. Tau really does run pretty much everywhere. You can analyze most languages that I can imagine you might want to analyze for high performance computing, and even some you might not. So we've got Fortran, C, C++, and also Java and Python for good measure there. It's also pretty much tested on all major architectures. I think I have a hard time finding one that tau doesn't run on. But there's more of a learning curve associated with using this tool, and we're going to try to hit some of that learning curve today, and to give us some hints and tips and tricks for making that easier. So when you use direct instrumentation, then obviously you do need to recompile your code since you're changing it. So the way tau does this is it has something called a tau makefile. They call it a makefile stub. This is what defines how tau does the instrumentation. So you have these tau makefiles, and you have tau scripts. And the tau scripts will replace the invocation of the regular compiler that you would normally, the normal compiler name will be replaced by the name of one of these scripts, depending on if it's a C code, you use this one. If it's a Fortran code, then you use this one. And there's a CXX version for C++. So the most basic thing is if you had a module for tau, you load the module, set this environment variable tau makefile to one of the tau makefiles. And the name of the makefile tells you what it's configured to do. All of them have makefile.tau. -PAPI means it's configured to use PAPI counters. PDT is an automatic source instrumentation package. So this is what makes the instrumentation happen behind the scenes so that you don't have to go in and manually insert all these function calls. That's what PDT is. And then this is just the name of the compiler that tau is replacing. So if you want to compile your code with Portland group compilers, then you need to use a makefile that was generated with those compilers. And then there's various options that will control what tau does when you actually run. So these are runtime options here. These are the options that control different options that you can set when you actually make the code, when you actually build the code with Tau. So you can, for example, this is. Yes.
I have a question from Northwestern.
Sure, go ahead.
For on any given shared cluster, when you have dozens of different compilers and MPI and OpenMP, does that mean that you could possibly have a dozen different configured makefiles floating around, or do you have to reconfigure Tau every time you work with a different code?
You would have dozens of these makefiles, so you'll have a path where Tau's installed, and when you compile Tau, then you can give it a bunch of different configure options which tell it which combinations of makefiles to use. Okay, so you could, when you build Tau, just sort of take the kitchen sink approach, and you could have it install a makefile for every conceivable combination on your system. So you could write a script and do that. But yes, you do need to have a makefile for different combinations of MPI flavors and compilers. But that's kind of that's a one-time thing that you do when you install Tau. It's not every time you run your application, or you just install Tau with all those different configurations, and then when you pick, if you have those, once you have those available, then you're set. Until something changes on your system, or you have a new compiler or something, then yes, you have to deal with that if you want to use that with Tau. But once you have all those configured, then you just need to specify the right. Just need to set this environment variable to the appropriate makefile that has the combination of compiler, MPI flavor, and Tau options that you want. So this is a step up in complexity, no doubt. But for once you have, so this is configured already on a lot of systems with a lot of the default combinations for that system. So if you're running on an HPC system that has Tau, then chances are one of the things you want is already there. And if not, then someone can configure it for you. It takes a minute to make another one of these makefiles, to run their configure command, and it will add another option there if the one you need is missing. Does that answer the question?
Yep. Thank you.
So when you actually go to build your application, you may want it to spit out a lot of information about what it's doing. So there's an option for verbosity there. This is really useful, this option to keep files. What this does is it keeps the intermediate instrumented files that Tau creates. So you can actually go in then, after you build your application with Tau, you can go back to the source code, and you'll have all your regular source files there, but you'll also have the instrumented versions that Tau is now going to run. And you can see exactly where Tau put those function calls. And so you can see the syntax there in case you wanted to go in and do anything by hand. It's a nice way to see how it's done. And it also can alert you to maybe issues, but we'll hit that in just a second. You set this environment variable to the right makefile. You set this to take care of any options you need at compile time. And then you replace your call to whatever Fortran 90 compiler you were going to use. You just replace it with that. And everything else on your compile line remains exactly the same. And then away you go. So this is just this link here is something that I would recommend everyone sort of take a look at, maybe after or during, whatever, this talk. Because there's a number of options that are available both at compile time and at runtime, and this sort of gives a nice summary, quick reference cheat sheet of I think most of those, certainly the most commonly used ones, and also how to use it in different situations. And there's other documentation too that gives you examples, but this is a nice kind of one place to go to kind of refresh syntax and see how to do certain things. Now, if you have a makefile that you want to use Tau with, again, you just set this environment variable to the tau makefile, which doesn't in any way replace or doesn't really have anything to do with your makefile at all. You just need to set that environment variable. You set your options as normal, and then you just call make. And for example, if in make you have the variable fc that points to the compiler you want to use, then you wouldn't even have to modify your makefile. You could just tell make that you want this variable, instead of what's actually in the makefile, you want this variable to equal, instead of equaling whatever PGI F90, it now is going to equal tau underscore F90.sh. And that would compile, and then it would compile. So with tau. So after you do this, then you just run the code as normal. So you don't need to do anything special. Once you've done the instrumentation, it's built in to your code now. So you just run the code with the normal MPI command. And then there's pprof to get the text, to get some analysis in text format, or paraprof, which I'll show you more about later, which is a GUI which has a lot of nice features for showing, looking at performance.
Question from UCLA.
Is there a question?
The makefiles you are talking, they are the same makefiles under the inside the lib directory where tau is installed, right?
No.
On Rangers.
So right. So well. Oh yes. So okay. So let's be very clear. So I tried to. So there's the tau makefile, right? And you have nothing to do with that makefile. It's installed somewhere. You set an environment variable to it. Tau just needs to know where to find it. That's it. Okay. But then if you want to, but what I'm talking about here is if you have your own makefile for compiling your code, which has nothing whatsoever to do with the tau makefile that you set your environment variable to. It's just your own makefile. This is how you would do it. You would set those environment variables just like you did before in the command line example. So this is compiling on the command line. So you set those environment variables just like before, but now instead of compiling it on the command line, you're going to use your own makefile for your code, and you could edit your makefile and replace whatever value you gave to cc or to fc or cxx or whatever variable in your makefile points to the appropriate compiler. You change that value to the appropriate tau script, which is defined appropriate, meaning what language are you using. If it's Fortran, you use this one. If it's C++, you use tau underscore cxx.sh, and if it's C, then you use tau underscore cc.sh. So you just point your makefile to the appropriate tau script, and that will do the instrumentation. Is that clear?
In the beginning, I got confused between the makefile in the tau directory and the third line is our own makefile.
That's right. The third line refers to your very own makefile, and you never ever do anything with this tau makefile. It's just you just point tau to the right one, and that it just defines how tau is going to instrument your code and other things that tau needs to know about, but not you.
Okay.
That's obviously a problem of that needs to be clarified there. So, but then once you do that, you set these two environment variables. You replace the name of your compiler with one of these tau scripts, and it'll compile. And then you just run the code as normal. So here's if you want to use the GUI, and this is why, by the way, we had you download tau and install it on your local machine, is so that you can get this analysis tool paraprof on your machine. So you don't need to install all the options for tau to actually do instrumentation. You just need this paraprof binary, but it comes it comes in the tau package and just kind of all installs as one if you have Windows or Mac. So anyway, this paraprof tool, if you run it on the command line on the remote machine and give it this -- pack option and then the name of a file with a .ppk, it will pack. So when you run the code, it will generate a bunch of files named by profile dot, and then it'll give you the name of the task that it ran on. So it gives you there's a bunch of files that will end up. So this command will pack up all those tau profile files into one single file that you can easily copy back to, say, your workstation. And then you can use Paraprof, if you've installed it on your workstation or laptop, you can use this GUI tool to do the GUI stuff on your local machine,